Hello and welcome to today's session, which is a product training session on Algeos 3D. My name is Louise Fisher and I am a podiatrist with experience in biomechanics, MSK and all things orthotics. So I hope to take you through today's presentation with all that experience in mind. Just a wee note before we start around the content that we share throughout today's session, and you're welcome to take pictures and notes down, obviously, in relation to the content and the slides, but the property that we share today is all of Algeos 3D and Algeos property. So the plan for today's session is to really take you through an overview of Algeos 3D custom foot orthosis range. We want to take you through some of the reasoning that you might make to guide your custom orthosis prescriptions. We will take you through step by step the platform on how to create a custom prescription. And we'll also go through some of those expectations that you may have as a prescriber using the platform, or also that you may have come in as a question from your user as they go into the experience of custom-made foot orthosis with you. Okay, so that's a good start and a good introduction. I'm going to take us through the rest of the presentation to dive a wee bit deeper into Algeos 3D and what it's all about and everything you need to know as a clinician who is keen to get involved with Algeos 3D products. What is an orthosis? So we're talking today about Algeos 3D. We're talking about 3D orthosis. We're talking about custom-made orthosis. But what they are ultimately is an appliance to support, align, correct deformity or motion around different parts of the body. Foot orthosis obviously address the foot, the lower limb. So we are talking about custom-made foot orthosis today. What is the current state of 3D printed orthosis? Well, this is a great read and a great paper to explore. So recently published, it really looks at the current landscape of 3D printed orthosis and clinical outcomes with that. The paper explored different body parts, so it's not just isolated to a foot, but there was a particular section that was reviewed under the foot. And really 3D printing and its use in foot orthosis is, it has so many advantages, and we're very much in this stage of transition into digital landscapes, digital printing, digital materials. The joy of 3D printing is that it allows us to get a very personalized orthosis. It allows us to improve the fit, the comfort, and the effectiveness of it. And there was a lot of benefits found through this report and this research in relation to efficiencies. So efficiencies around production time for the orthosis, efficiencies around waste, and a significant reduction in the amount of waste during the manufacture process using 3D materials. A high level of precision, both in design and manufacturing stages. And when you get efficiency, when you get sustainability, and when you get precision, ultimately all of that starts to eliminate human error and human risk that's associated with this procedure. So that is a really nice paper to read and explore, but I've obviously just given you an overview of the current landscape of the benefits of transitioning into 3D printed foot orthosis in your clinical practice. So again, what does the evidence say? What are we looking at in terms of how good are they? What are the outcomes like? Highly recommend this paper, which explores 33 studies using 3D printed foot orthosis. And what was interesting across these studies is it looks at so many different elements in terms of clinical outcomes. So you'll know as a clinician, there's not just one clinical outcome. There's not just one reason why you would choose to make a custom-made foot orthosis, or there's not only one reason why you would choose to make a 3D printed material device. So this explores the different designs that are being used around 3D printed orthosis. It's looking around the different stiffness levels, and also comparisons between traditional and more digital methods of custom-made manufacture, as well as the debate around the prefab and the custom-made prescriptions. Interestingly, across all these papers in this systematic review, the consistent pattern that was observed was often in favour of the 3D printed orthosis. So in terms of clinical outcomes, regardless of what the individual study was looking at and exploring, ultimately the favour was in favour for 3D printed orthosis. So that's a recommendation if you're considering, should I be moving towards 3D printed foot orthosis? This paper would absolutely suggest, yes, you should. If we look a little bit further back into the evidence base, so not too far further back, but the experience of custom-made foot orthosis, particularly in a podiatry landscape, hasn't always been so favoured. And we know there's lots of different professions that do use custom foot orthosis, namely podiatrists and orthotists. And this small study focus group looked at some of the challenges and tried to unpick some of the themes that arose from podiatrists and their patients who used custom foot orthosis. And there was a couple of themes, 3 key themes that were identified through the focused group. One was experience, one was about the process, and one was about the technologies. Now, experience was really in relation to the practitioner and the prescribing practitioner. The process is all to do with workflows, work streams, and the technologies, as you're well aware, we've moved drastically over the last number of years from traditional manufacture to digital technology manufacture and CAD/CAM processing. So that has absolutely influenced the journey of custom-made foot orthosis. And as we talk today, I'm talking to you under the lens of a completely digital workflow for custom foot orthosis, which is Algeos 3D. So within this paper, what they found was the key kind of pain points that was impacting outcomes was that all the language was different. All the lab forms were complicated. None of them were the same. They all asked you different questions. They all were maybe asking you the same thing, but in a different way. They were using different terminology. And the other concern was that there was so much interpretation related to what you put on a form as a clinician, what the lab interpreted from that form, and then how the lab technicians would then alter and modify and create the mold in order to give you a finished device. And it was believed that as a clinician who was patient facing, who was creating the prescription, there was a real lack of education, really through their training program, but also just in clinical practice, in order to get good outcomes at the end of the journey for that patient. So these were all the kind of pain points that have been highlighted as the custom-made foot orthosis journey. But then on the other side to that, we've got research suggesting that 3D printing and technology and digital tools are miles ahead in terms of precision, efficiency, etc. So ultimately, it gets us to a point of we need to move. We need to be in this digital space for all the benefits just mentioned. But what we need to do is make sure that we don't leave clinicians behind, and that clinicians actually know how to use the technology to benefit from the advantages of that technology and that tool. And that ultimately takes us to Algeos 3D. What is Algeos 3D? It's exactly that. It's a fully custom digital workflow solution, which has been engineered to be different. It's considered all the challenges that we have in industry and in manufacture and in clinical practice. And we've blended all of that together to create a digital solution, which is reliable, it's simple to use, it's intuitive to use, but it also finishes with the precision and the spec that we would require and desire from digital technology. So there's three parts really. The first is the design. So Algeos 3D, it's an open and flexible design. So you can import scans or you can scan directly. Again, we would advocate for a digital workflow, but there is the option for a hybrid system where you can scan in traditional methods of capture. There's clinician-led prescriptions. So based on past research and evidence in clinical practice, there's evidence-based presets to allow a quick prescription and also a reproducible prescription. Or you also have full custom control. It allows you to do exactly what you need and know what you're doing is what you're going to get. And it comes at no cost, which means it's barrier-free to use. You don't have any particular subscription rates at this moment in time to allow you to access the system and the software. The second part is the delivery. So we talk about efficiencies and we talk about speed, and with that, there's a 7 working day turnaround. So Algeos 3D offers a UK manufacturing process and a turnaround time of 7 working days from placing your order. We create custom-made PA11, or you'll also know that as nylon 11 shells. And we do have a selection then of top covers that are interchangeable with the shell device. And we also provide a significant amount of support. So there is support beyond the product. The product has its features and benefits, and we go through some of that throughout today's presentation. But what we also have is support for you as a clinician, and support for you as a practice, and a support for you as a business as well. We have marketing tools and forecasting tools and lots of different business support available to help you to adopt in Algeos 3D into your clinical practice. And as you can see here, just a little demo of, you can access it for free. So it's simple to just log in, algeos3d.com, log in, sign up, and really start to have a play with the system. And then ultimately you buy what you use. If you decide to print a pair of custom foot orthoses, then you pay per product. I want to take us through that process of the custom foot orthosis and the step-by-steps involved. And as we do that, I'll take you through elements of the system And then hopefully this will help you experience, when you do experience Algeos 3D for the first time, you'll see that the workflow is very seamless and intuitive based on this format. So foot orthosis, if we're doing a custom-made foot orthosis, you've really got 3 stages. The very first is foot shape capture. You need to understand the foot that you're trying to capture. You need to understand what it is that you're trying to grab from that foot. And then you choose and get an appropriate method to capture the foot, which gives us the initial data points and data sets. You then move into your orthosis design stage, which is when you create your prescription, your spec, your material choices, your features, your benefits. You know, you play with all that, and that's the joy of a custom control. And then the third step is the manufacture, which as a clinician using Algeos 3D, you're not involved in the manufacture. You just press send and your product will be manufactured to high quality and delivered at your door 7 working days later. Foot shape capture. So this is a great debate, and we have plenty of support around this topic of conversation in other areas of our education and training. However, what I would highlight is, what are you trying to achieve with your foot shape capture? And it is important that how you capture your foot, regardless of whether you are using traditional methods, which may be a foam box or plaster Paris. The modern day technology is mobile scanning apps and flatbed 3D scanners. But how you decide to take a scan will impact the data set that then creates your insole. And we said there's very little human process in this. This is a fully digital process. So what is very important to note is the data that you get from your scan is going to feed through every step of the process. So what does that mean clinically? Well, it means if you take a weight bearing scan, that foot data will be different if you take a non-weight bearing scan. A non-weight bearing scan, you'll have a generally a higher arch profile. You'll generally have a narrower heel and a narrower foot width than you would if you were semi or total weight bearing. If you're trying to control a foot and stabilizing a foot, then a weight bearing impression may not be the best technique if the foot collapses under load or it isn't going to function the way you wish under load. You may want to control that capture so that can replicate into your device. So knowing the nuances of scanning, whether it be Algeos 3D flatbed scanner, which is currently available with the system, or whether it be an Algeos 3D mobile scanner, which is currently in development for the system, both options give you choice to choose a non-weight bearing, a semi-weight bearing, or a fully weight bearing foot shape capture to feed into the system. This is the type of impression that you would gather from a flatbed scanner. And what is quite nice here is you can compare semi-weight bearing and fully weight bearing data points. You've also got your comparison between your left and right. But the key thing is you basically have a reference point. Because you've got the glass as a push point and a force point, you typically do tend to get a slightly wider foot parameter, and particularly a slightly wider parameter at the heel, which you tend to not get in a non-weight bearing impression. This is typically the type of kind of mesh scan that you tend to see from a mobile scanning app. And again, you can see that you have less control of parameters within the foot. So how the forefoot sits in relation to the hindfoot, how plantar flex the ankle might be, is the forefoot ab or adducted off the hindfoot. You need to try and control those parameters. But that's not necessarily any different to what you would have always done when you took a plaster Paris. You're just taking those same key points into a digital landscape. When you think about what you would have always done with a foam box impression, that's that same kind of landscape moving into the flatbed scanner. It's the same clinical principles, but in a different environment, really. So once you have the foot shape and you've taken the capture, you then basically have the capture within the Algeos 3D system. And here it shows where you've got your data sets and your data points. So you can upload the scans into the scanner. You can upload the scans into the system, or the Algeos 3D scanners are certainly able to be connected into the system directly. And then you have to allocate your little data points onto the first, the fifth, and the heel in order to translate into the design stage. And this is a very important stage of the process, the first stage of the custom process, to allow you to get your product designed and printed. Next, we think about the orthosis design then, and this is where you have full control to do as you wish. We've got different parameter sets, so the technology is smart and data is smart if it's programmed correctly. So your design prescription, this is in essence a digital prescription, and it is there to capture data, patient data, predominantly on this screen. But there are certain algorithms within the system that can connect. For example, the weight of the patient that you put in will connect to the thickness of the shell, which will link to the level of rigidity that you provide in your final foot orthosis. Excuse me. What we also have here is a number of kind of preset parameters, which allow you very quickly and easily to shift between elements. So if you wish to change the width of the shell, or if you wish to increase or decrease the arch height of a device, you can click on simple templates here, any of these, and you can start to alter and change the prescription variables of your final orthotic product. Then you come into the main orthotic modeling system, and traditionally we don't see this. When you send traditional custom foot orthosis prescriptions away to a lab, as a clinician, you kind of wipe your hands of this and say, I don't have anything to do with this. I don't need to know. Hopefully I get back what I want. We've taken all that back into your hands, but in an easy, understandable way. And what this system allows you to do is literally look at that screen and pick the spec that you want. So you have a list of 6 presets here, which are all evidence-based specs. And what they do, you click on one of them and it'll auto-populate the commonly used prescription in clinical practice for that pathology. You can take it on, take it off, you can increase it, you can decrease it, you can still fully control it off that, but it is just to give you a starting point of working parameters that we know is linked to certain conditions based on previous research. The other option that you also have is to pick any individual spec from the forefoot, the midfoot, the hindfoot, click that into the shell, and you can see them appear along this profile here, the picture. So you think what you're doing, you click on what you're doing, and you get a label of what it is, and then you see it appear in front of you. So you get a very clear visual of, yes, this is exactly what I need and what I want. And this hopefully correlates to what you've always done in clinical practice. Regardless of how you prescribe foot orthosis, you're always thinking about the hindfoot, the midfoot, and the forefoot modifications and what impact that's going to have on gait. So exploring the preset pathologies, as I mentioned, there's 6 presets: plantar heel pain for a functional state and for an accommodative state. You've got one for second MTPJ plantar plate dysfunction, posterior tibial tendon dysfunction, Hallux limitus, and chronic ankle instability. And people may ask, right, well, where did you get the evidence? You say they're evidence-based. How are they evidence-based? We explore a couple of papers where we've really explored the evidence, explored the data out there, critiqued the evidence, more importantly. And if we look back on a couple of previous lab reports from 2017 and then later on as well, looking at what are prescription practices across the board for foot practitioners, what are they doing? How are they using it? What are they speccing out? Well, this paper really found kind of 3 particular patterns and types of spec that were constantly being provided and requested from the labs. There was a number of different modifications, and here you can see these were what was commonly used. So your medial skives, your lateral skives, maybe a heel shave, maybe plaster fill, no plaster fill, cuboid notch, 5th ray grind, plantar fascia groove, first met accommodation, heel expansion, medial flare, medial wrap. So these were the kind of common cast modifications. Now, in a digital landscape, we don't have the same divide of cast modifications and then orthotic modifications. In a digital landscape, you basically do it all within the design stage. So we've looked at what's been done as cast modifications. And we also looked at another paper, which was over 1,000 prescriptions, predominantly across New Zealand podiatrists. And it looked at all the different characteristics. So again, the shells, the materials, the thicknesses, the styles, and then the modifications and the additions that were coming together. So you can see here the different, they're quite similar, same kind of pattern of spec coming through. And then that basically allowed us to pull out and see what are the common clinical practices. And you can see here what the common specs were. So from the most recent study, which was published 2025, the shell materials most commonly used, as we are in industry, moving to PA11 and more sustainable materials. You have got 3 millimeter shell thickness, but again, within Algeos 3D, we allow that flexibility to adapt to patient demands, patient weight. Theory behind custom fit orthosis and the functionality behind custom fit orthosis, we have evolved over time in terms of our traditional root practices into tissue stress practices, into many other paradigms and theories. And some of what we see is probably deep set rooted prescription practices, but we are also in a space of that needing to change as we move into a digital landscape. You can see here Kirby skives were very commonly used, as was full length top covers, prescribed in 87% of those 1,000 specs that went out the door. So what are the presets that you can experience within Algeos 3D? Looking at the plantar heel pain functional, 3 millimeter lateral forefoot wedge with standard heel posting, standard heel cup depth, and a 3 mil medial hindfoot wedge. In terms of an accommodative state, we're looking at a standard heel cup depth for control and lack of displacement of the plantar fat pad, and a heel aperture for offloading purposes in relation to that would then connect to the thickness of the shell. So it is a complete aperture, a complete hole at the heel, obviously then covered with your top cover. From a second MTPJ plantar plate injury, and obviously this is very easy to modify for a third or indeed a fourth pathology, but this requires an extension of the length into sulcus length, allowing you to have a cutout under the sweet spot, shall we say. 5 millimeter met domes, again with a standard heel cup to give you that stability, the offloading and the functionality around the MTPJ and the plantar plate, and then the offloading during propulsion phase of gait. Posterior tibial tendon dysfunction, we're looking at much more medial column support, much more stiffness, and with that having a medial flange, a stable heel post, and both intrinsic and extrinsic medial heel wedging, and a deep heel cup to accommodate those parameters. Hallux limitus would involve a first metatarsal extension, again with a standard heel cup, to get that full stiffness through the first ray, creating rigidity during propulsion. And for chronic ankle instability, looking at that lateral stabilizers, so some lateral extrinsic heel posting and lateral wedging around the lateral column and external border of the foot. With that said, though, you still have full custom control. So as I mentioned, you can go through any of these parameters and pick and choose as you wish. And you've got lots of option then to specify. So at the forefoot, you can further alter the width of the shell as standard, narrow or wide, or region specific in the forefoot, midfoot, hindfoot, or in terms of thickness, ranging from quite very flexible at 2 mil up to very rigid at 3.5 mil. And then all the different prescriptions at the forefoot, the midfoot, and the hindfoot, you've got a choice of, we've kept this as not an overwhelming choice. So we wanted it to still be intuitive. We wanted it to still be manageable and not overwhelming. So we have kept the limits to low, moderate, and high spec, because it can get very overwhelming if you've got 20 millimeters of parameter to choose from every orthotic spec. And we didn't feel like that was necessary or needed in terms of clinical practice for this. So you can see all the different forefoot specs there and your ability to alter them. Similar again for the midfoot, your ability to alter them. And similar again for your hindfoot with the ability to alter them. And then clinicians will tend to get their own preference. So you may already have your own preferences. So when you learn to work with the system and the materials, you will develop your own tricks and traits and patterns that you do as a clinician. And then the final stage, once you do the design, is obviously then send it off to print. And our Algeos 3D products are printed, as I said, with a PA11 shell, also known as nylon 11. And that is done using a HP multi-jet fusion 3D printer. If you're not aware of 3D printing, I'll make you aware right now that there's lots of different types of printers. How they work and how they print is different. And different printers can print different materials. So that is a space that you might want to go and explore further on. But for the purposes of today's talk, I'm letting you know that our Algeos 3D products are printed in the UK and are printed with a HP multi-jet fusion 3D printer using PA11 materials. Product selection. So talking about the material, PA11, what is it? What is it? Why is it different? Is it just the same as our traditional materials that we've always used, like polypropylene or carbon fiber, or is it different? And the answer is it's different. It's new. It's a new material with its own new properties and with that exceptional qualities compared to some of our traditional materials. So it is a bio-based polyamide material. And it's actually derived from renewable castor oil. So it's 100% bio-based material, which really, really supports the transition on a sustainability journey. It's used with powder. So actually there's quite a high ability to reuse the powder, which means that there's very little waste, which obviously then impacts that sustainability journey as well. And the PA11 material is got compliance as well in relation to your ROHS and your REACH compliance. And it is also compliant for use of skin contact. So it can be used as a standalone shell with no top cover, or you can use a top cover with it. It is suitable for either or option. Some of the clinical benefits from it is in relation to the strength of the material. It's so light, it can be so thin, but it can be so strong. So you can bend and flex this material as a whole material or within parts of the material to get just so much precision and control in terms of where you want force applied and where you don't. And obviously, I've talked about the benefit of the precision and accuracy of printing a material like this rather than traditionally hand making it. And it is a very stable material. So in relation to sweat and oils and chemicals, it's very, very resistant to all of those. A key feature of Algeos 3D is a system called X-Fix. And this X-Fix system is new technology. And what it allows is basically a hook and loop system to adhere your top covers to your shell. So we're eliminating the need for adhesives. We're eliminating the need and the faff around having to repair and replace top covers, because the X-Fix hook and loop system allows very quick and easy, readily adjustable top cover replacements, mainly by the patient, but it also makes your life easier as a clinician in order to be able to offer that service. It means that if there's any sign of wear on the top cover, which we typically know the top covers, the softer foams, will wear much quicker than the denser and firmer shell materials, it allows us to replace and reuse, but while still getting the benefit of the original device and the original control that was prescribed in the custom fit orthosis. I want to touch through some of the different top covers that we have as well, because with Algeos and Algeos 3D, we've very much blended our material science and our wealth of knowledge that we have in materials industry to get this combination of materials and prescription right. And we've created 5 top specs, really. First, I'm not going to go through this in specific detail, but we've got a slide on the specification and we've got a slide on the technical spec, should you wish to read it in more detail. The sports specification allows us to use the Pour-On Green Vive as a mid-layer, which gives us excellent cushioning and absorption and shock absorbing abilities for your sports applications. Full length cover, it's got a bottom layer which allows the hook and loop system with the X-Fix, and then it has a LeatherTech top cover, which is a breathable material, sweat resistant. And the finished depth of the material top cover is 3.2 mil, and it comes across the range of foot sizes as well. Your everyday spec, again, just everyday wear, ideal for comfort, involves and includes the grey Pour-On 4000 performance material for cushioning, and again, the LeatherTech top cover. We have a maximum impact protection cover, and this is for anyone that is doing a lot of high impact activity or spending a lot of time on hard, impactful surfaces. And for example, factory workers or anyone that's on their feet on hard concrete surfaces all day, the LeatherTech performance cover, so with the yellow XRD Pour-On as a combination top cover for Algeos 3D would be recommended. And then finally, we have 2 specs which are dual purpose. One is a care for the hindfoot and one is a care for the forefoot. And what we've done is we've zoned the different densities of Pour-On in order to get a softer, slower rebound, either at the heel or at the forefoot, depending on whether someone presents with a hindfoot or a forefoot pathology. And you can see this example here is the hindfoot. And then you can see the forefoot example. We've got that soft medical grade Pour-On at the forefoot in through as well. We offer market and support. So it's not just about the product, it's all about the brand of Algeos 3D and what it offers. And with that, you can see there's the packaging solution that comes with the product. There is QR codes for patient information leaflets, and there is lots of digital paper if you need, but digital systems such as branding for your clinic, branding for that you can use on your website and your socials, and lots of promotion tools that you can use to market this as a product as part of your business offering. And above all that, as I've mentioned at the start, what's most important is that we are here to support you. We've designed a very intuitive, free-flowing system, but often we sometimes need help as well. So we are here to provide that if you need help. And we have help for sales inquiries, for technical support, And we have lots of other educational support under Algeos Academy, should you also need to explore that from a clinical and a prescribing perspective. I'll leave it on this last slide, really just to consolidate where we are with Algeos 3D, and I hope that you've enjoyed the experience and what I've talked through today. But it really is built on Algeos's legacy, which has been over 140 years where we have been committed to materials and orthotic innovations. Algeos 3D is a blend of all of that. It's been trusted and built with clinicians and lots and lots of people. So clinicians, experts in marketing, experts in CAD/CAM software, experts in design and product development, and created a really efficient, simple, intuitive, effective software system to help you as a clinician adopt sustainable practices for using custom fit orthosis, but also to allow you to offer products, which is the direction that we are taking in terms of clinical practice and evidence base. It's where it's at, and Algeos 3D are allowing you to facilitate that in clinical practice. So thank you for your time today. I hope you have enjoyed the session. If you do have any questions, you can reach out to any of the team, and I'll leave just my last couple of references on the slide as I finish up the session. Thank you very much for listening.